Thanks everyone for coming and joining this workshop. My name is Adam Kortylewski, and I'm going to kick off now our workshop and challenge on out-of-distribution generalization in computer vision. It's hosted here at ECCV 2022 virtually. And let me first start with a few big thank yous. First big thank you goes out to all of the organizers who made a huge effort to actually make this workshop possible. And these are Bing Chen Cao, Jiahao Wang, Ziwei Yang, Shou Zuyu, Dan Hendricks, Oliver Zendel, Dawn Song, Alan Yule, and myself. We actually made a lot of effort to make this challenge happen and organize everything around it. Another big thank you goes to our program committee, who invested a lot in reviewing submissions, long papers, short papers. We're going to announce the best papers at the end of this presentation. And the final big thank you goes out to our sponsors, the Future Fund Regranting Program, who funded the prizes for the challenge, and the i.i.d, Austrian Institute of Technology, who helped us annotate some of the data that we used for the challenge. Now, let me start with the motivation for this workshop. When we look at the current state of computer vision, what we see is that we actually achieve pretty high performance across a wide variety of tasks. So image classification, challenging ImageNet data set, we are far beyond 90% by now. Semantic segmentation, really challenging computer vision tasks for decades, right now almost solved, at least on data sets. We do stuff like panoptic segmentation, which is like extremely challenging task. So we not just do semantic segmentation, but also want to label individual instances. Seems to work quite well. We achieve human pose estimation, like far beyond human capabilities, down to 7 centimeters from a monocular image. And we are even asking machines pretty difficult questions, like, for example, this one here. What is the material used to make the vessels in this picture? Which like really requires a very deep understanding of an image, right? So what is a vessel? Where is it located? How can I kind of extract material properties, disentangle this from the illumination, just to enable the answer, which is then copper, right? Like really intricate, difficult image understanding processes that need to go on here to answer this question. So, oh, that's a second slide. So what we've seen is there's lots of progress that happened in the past decade, and many of the challenging data sets that were considered actually challenging like 5 to 10 years ago are saturated by now. And this kind of gives them impression that actually computer vision might be solved, right? We are like very close to getting there. And then, you know, like the perception part of autonomous systems seems kind of resolved. But that's unfortunately not the case. There's lots of research, a decent amount of research that actually shows that deep networks are not robust in out-of-distribution scenarios. So what do we mean by this? The number of works that show that if you show an object in an unusual context with respect to the training data, for example, like a car in the desert, it was not seen before, and at training time, these methods fail. Right? Same happens to unusual textures or cars that are seen in unusual pose, difficult weather conditions, or what we have studied, for example, in our group a lot, the partial occlusion. So when one of those things, of these variations, is not like observed in very much detail at training time, at test time, these methods do not generalize well. Now, the issue is, why is this an issue? The issue is that autonomous systems actually, let me go back to the slide, is that autonomous systems actually, what will happen in real world scenarios is that these autonomous systems, they will face these challenges and they will need to generalize in these cases. So on the one hand, we see that our academic benchmarks basically measure 99% performance and tell us computer vision is solved. And then on the other side, we observe these scenarios here that tell us, oh, our vision systems are actually not very sophisticated, because all of these scenarios, they do not fool a human observer, right? There's this discrepancy between our academic benchmarks and what we observe in real world scenarios. And the problem with this, and why we observe this, or the cause of this kind of discrepancy, is that our academic benchmarks really mostly measure i.i.d. generalization. So in distribution generalization. This means that with respect to our training data, the test data looks pretty similar, right? And therefore we achieve these very high performance gains. And now we need out of distribution generalization, and the current most popular way of evaluating out of distribution scenarios is paper by Dan Hendricks, who's also a co-organizer of this workshop, at 2019, I think, where they introduced these synthetic image corruptions and showed that deep networks are not able to handle most of those. Right? So by now, actually, this is a pretty standard measure of out of distribution generalization. Right? So you add a little bit of noise, visible noise, and check if your model generalizes well. The issue is that these corruptions are synthetic, and it's unclear if models that generalize to Gaussian noise will also generalize to unseen 3D poses or unseen textures. Probably this is not the case. So that's what we thought. And this led us to develop this new type of benchmark, out of distribution benchmark, where we collect a set of training data, i.i.d. training data, and with respect to the distribution of the training data, we collect out of distribution data. So data that looks unusual with respect to the training data. And these images, they look like this. So we are showing I'm actually showing cars here all over the presentation, but we have, of course, more objects. And what I show here are also images that are used for classification, but we also have detection and 3D pose annotation as tasks that we annotated. So we have these unusual scenarios, so cars in unusual contexts, weather or occlusion. And what we observe is that there is a huge performance drop, right? So this is in line with prior work. But interesting property of our data set is that we not just collected this out of distribution data, but we also annotated individual nuisances. So we know exactly which test data actually varies with respect to what nuisance. So there will be one nuisance variable, for example, shape. It will be cars that have a different shape, but that look pretty similar in the other nuisance factors with respect to the training data. And there will be individual nuisance, like training data, that will vary only with respect to pose, but will have like a very common shape. And by classifying these individual nuisance factors, we are able to decompose this one metric, classification accuracy, into the different nuisance factors, which enables us to, for example, observe that partial occlusion or weather variations are a lot more difficult to handle for image classification models compared to, for example, context variation. And these numbers, they vary significantly also between tasks. So for example, what we discovered is that in object detection, the context variation is actually the one that is most challenging for object detection models. Good. So we collected this data set. This paper will be presented at ECCV as an oral presentation. The big question remains, how can we improve out of distribution generalization? And to answer this question, we've organized a challenge here at this workshop. 3 tracks, one image classification, one object detection, and a 3D pose estimation track. And we had prize money funded by the Future Fund Granting Program for the first 3 places in this track. And the first place winners will also be invited to contribute to an IJCV special issue on robust computer vision. One more word on this, or a few more words on this IJCV special issue. This IJCV, this special issue has 2 tracks. One track that is open to everybody, and we encourage here everyone to please submit their work on this special issue, with a submission window, I think, will open late November or beginning of December. And then there is a second track where we invite only the winners of the robust vision workshop, which happened yesterday, and the out-of-distribution generalization workshop. So please consider submitting your work to this IJCV special issue. Now, in addition to those, to the challenge, basically asking the community to provide answers to this very difficult question, we also invite several speakers, experts in the field who will tell us their opinion about out-of-distribution generalization. And we are going to start soon with a talk of Pietro Perona. Afterwards, we'll have Javier Bois and Alan Yule. Then we'll have a poster session, short break, and a poster session where the paper presenters will have a short video or a live presentation of their works. Afterwards, we are going to have a session after the lunch break where we introduce the challenge winners. First introduce the challenge and summary results, and then individual challenge winners will present their results, their approaches. And then afterwards, in the afternoon, we start with 3 more invited talks. Karl Wondrich, Alexandra Madry, and Olga Rosakovsky will present their opinions about out-of-distribution generalization, and we will close with a very exciting panel discussion where all of the invited speakers will actually take place, will join, and this will take place at 4:30 p.m. Israel time. So those 6 experts will tell us what to do with what we shall do to achieve out-of-distribution generalization. Importantly, here to ask questions, there is one option, which is you go on the ECCV platform and click here and type in your question. This will be important for the live talks, for the poster sessions, as well as for the panel discussion. And we will have a close eye on this and monitor this to kind of make sure that we pick up every question that is asked here to ask the speakers. Now, final slide. Let me announce the best paper awards. The best long paper is domain condition normalization for test type domain generalization. And the best short paper was the value of out-of-distribution data. We thank both teams for submitting their works. They've been notified, and please reach out to them after their presentations in the poster session later today. So with this, I'm going to close the opening remarks. Thank you, everyone, and I'm going to hand over to Bing-Chen Zhao, who will host the morning session and who will now introduce the invited talks.